Hello and welcome to GonitSora.com. This is the fourth problem in our series Simple Concept Tough Problem. So today we will be dealing with a problem which came in the PRMO exam 2017. As you can see on the screen, if an integer x, a natural number n, and a prime number p satisfy 7x square minus 44x plus 12 equal to p to the power n, then find the largest possible value of p. Okay, so let us see how we can apply some simple or basic mathematical concepts to solve this particular problem. Okay, so here is the question. An integer x, a natural number n, and a prime number p satisfies this equation 7x square minus 44x plus 12 equal to p to the power n. Find the largest possible value of p. Okay, so let us start with this equation and go about simplifying it. So we may try this factorization, middle term factorization. So as you have I have noted here, 7 into 12, it can be written as 42 into 2, and 42 and 2 when added they become 44. Okay, so we can just factorize it using our middle term factorization technique. So we get p to the power n is equal to 7x minus 2 into x minus 6. Okay, now it is given that p is a prime number. Okay, that means this number on the left hand side has a prime factorization p to the power n. Okay, so that means what, every factor here is of the form p to the power alpha for some alpha, right? Okay, so there are three possibilities. So let us list them. One possibility is 7x minus 2 is 1. In that case, the other factor will be p to the power n. Okay, another possibility is x minus 6 is 1, and in that case the other factor will be p to the power n. Okay, and the third possibility is p divides both of them. Okay, the first possibility is p divides only x minus 6. Okay, in that case x minus 6 has to be p to the power n. Okay, the second case is p divides 7x minus 2 only. Okay, in the so 7x minus 2 has to be p to the power n. Okay, so the third possibility is p divides 7x minus 2 also, as well as p divides x minus 6. Okay, so let us now consider these possibilities one by one. Okay, so if let us see if 1 and 2 are possible, and so we will see if 1 and 2 are possible, and we will use some divisibility properties to deal with the third one. Okay, so in case 1, what happens? 7x minus 2 equal to 1. So this will imply x is 3 by 7, but this is not admissible as x is an integer, right? So the case number 1 is not possible. Okay, so we can reject that. In case number 2, x minus 6 is equal to 1. That means x is 7. So x is an integer. So we can hope for some solution. So if we put the value of x in the other factor, so we get 7 into 7 minus 2 equal to p to the power n. That means 47 is p to the power n. So once we get 47 equal to p to the power n, we are sure that p has to be 47 and n has to be 1. Why? Because 47 is a prime number. Okay, so 47 can be written as only 47 to the power 1. Okay, right? So one value we have already got. One possibility is that p can be 47, right? Okay, now let us deal with the third case. Third case says that p divides 7x minus 2 and p divides x minus 6. Okay, so here we will use some basic divisibility properties. This property, d divides a and d divides b, this implies that d divides any linear combination ax plus by. Okay, d divides any linear combination of a and b. Okay, a into x plus b into y for all integers x and x and y, right? So this is what this property we will be using. Okay, d divides a and d divides b implies d divides ax plus by for all integers x and y. So p divides this 7x minus 2 and p divides x minus 6. This will imply that p divides 7x minus 2 minus 7 into x minus 6. Okay, so we choose the 7 in a clever way so that this quantity x vanishes. Okay, so that's how we are choosing, so that we deal with some fixed number. Okay, x is a variable quantity, so we are trying to remove x somehow. Okay, and by this divisibility property we can do that. So p divides, so whenever p divides 7x minus 2 and x minus 6, p also should divide 7x minus 2 minus 7 into x minus 6. So 7x will get cancelled. That means p divides 40. Okay, so now we are done. P divides 40 and p is a prime number. So what are the only possible values of p? 2 and 5. Okay, 40 is divisible by the only 2 and 5. Right? 2 and 5 means 40 has only 2 and 5 as its prime factors. Okay, that is what. So the possible values in the third case are p equal to 2 or 5. Okay, so what is the largest possible value of p? It's 47. Okay, so we have seen that this problem could be solved only by using some basic factorization that we have used here, prime factorization, that is middle term factorization, and some basic properties of prime numbers, or say prime factorization. Okay, the idea of prime factorization, and lastly we have used a property of divisibility. Okay, so these are very basic concepts which are taught in mathematics classes in schools as well. Okay, and we have used it to solve this particular problem. Okay, so this is the fourth edition of simple concept of problem. So we will get back to you with another such problem in the next video. Thank you.